All right, you're welcome back once again. My name is Victor Digomore here, and in our today's class, we want to start looking at coordinate geometry. This is the aspect we want to, start looking at. We have done a lot of class already. You can also check out those classes. This for your own good. All right, what exactly do we try to do in coordinate geometry? I will try to break it down. There are three things that I'm going to look at here. Three things. The first thing, Cartesian plane. Okay. So now in graduating this axis, assuming now I take a graduation like this, and I give this 5 units, 10, 15, 20. I'm just trying to give us a breakdown, and we need it. We need this breakdown because it's going to help us in the classes we are going to be doing. It's very, very important. Please take everything we are going to be doing here into cognizance. So assuming I give this graduation something like 2 units, 2, let's say 4, 6, and so on. This is my x axis. So you realize that, take a look at this point. A point here on this plane, can be said to have a value of y being 5 and a value of x being 2. Do we get that? So if I am making a mark here, if I make a mark here and I call that point, I call it P. I call here P. You realize that normally we write it like this, S, Y. Okay, that's how we present it. So this point P now, we have the x value to be 2, and the y value to be 5. Follow me. Now, assuming I pick up another point, say here, let's say alongside with this 6, say somewhere here, I think it's, yeah, okay, this 6, and I call it location or point Q. You realize, look here, look at this, okay, look at this, look at that, let me bring it down to this here, okay, and I call it point Q. You realize that this point Q, we have the x coordinate to be 6 and the y coordinate to be 20. Do we get? So now there are some things we might need to know around this whole thing. There are some things we might need to begin to study, verify, and begin to check around what we have seen right now. Now, those things are, we might be required to find the gradient of the line PQ. Gradient of PQ. Okay, this line, the gradient. Sometimes they say the slope. And what again? Distance PQ. Can also be required to find the distance PQ, and we can also be required, that's 1, this 2, number 3, equation of the line. Now, these 3 things is, and again, the midpoint. Can also find the midpoint of PQ. These things now is what I want to quickly look at. I believe it's not going to look like you spent your time without getting something. So the first one, let's go and take it. I'm sure that my explanation is very clear. So assuming I am looking for gradient gradient of PQ, that line PQ. Okay, you realize that gradient, I can give it a letter G. Gradient G is denoted by change in y axis with respect to change in x axis. And this thing, we can find it as the increment in y axis. The increment in y axis is that from here now, y is 5 to here, there is now an increment. So we will take, if we call here, let me bring in something now that can also help us. Do you see that at this point, I can call here the initial value of y1. Let me call it y1. And here, the final value of y, I'll call it y2. Do you follow? Here, I can call here the initial value of x, so I can call it x1. And here, the final value of x, I can call it x2. So you see that within here, there is an increment. Within here, there is an increment. So this increment will be y2 minus y1 over x2 minus x1. That's what gives us the gradient of this line. Do we get this increment over this increment? So let's look at it. Let's take a look at what it's going to give us. Now you see that y2 is 20. So my gradient G is 20 minus the initial, which is 5, over x2, which is 6, minus x1, which is 2. So this is going to give me 15 over 4. I can leave it as a fraction. Some questions in WAEC, when they ask you this question, sometimes they leave it as a fraction. I've not been able to see examples that they left the answer as far as gradient is concerned in decimal value. That's what I'm trying to point out. So you can check out the options. If it is in decimal value, fine. If it is in fraction like this, fine. You pick the correct one. Okay, let's move on. We have looked at the gradient of this line. Second is the distance between here and here. The distance between here and here. And in doing that, permit me to adjust this and make something here. Distance PQ. Okay. Now let me permit me to extract this triangle so that you can see clearly what I want to show you. Do you realize that this is now a right angle triangle? I'm sure you get it, because this line is running horizontal and this is coming perpendicular to it. And you know, when a line is perpendicular to another line, the angle there is 90 degrees. I'm sure that is not a trouble. So we have been able to understand that this is our y2 and this is our y1 and this is our x1 and this is our x2. And we have been able to understand from whatever we did here that between here and here is 15 and between here and here is 4. Now we are looking at something like, say, A. Do we get? That's that distance from here to here, the distance PQ. So that is simply going to take us back to Pythagoras theorem, which you use in solving the sides of a right angle triangle when two sides are given. So far as it's a right angle triangle and two sides are given, we use Pythagoras theorem to solve that. So let's take it. A squared, the hypotenuse squared, is equals to the square of the adjacent and the square of the opposite sides. So we'll be having 4 squared plus 15 squared, and this is going to give us 16 plus 225. All right, by my calculation, I have it as 225. 15 times 15 is that. So I have A equals to 16 plus 225. Of course, if you add it up, you are going to see that it is going to give you 241. 241. So my A, which is the distance PQ, will be root 241. Okay, you can leave it in this short form or you can get the decimal value, but all the same you have seen how to calculate the distance between 2 points on a line. All right, I'm trusting God that that explanation is very, very clear. The next thing I will look at quickly is the equation of that line. And the equation of that line, the way I'm going to look at it is recall. I will say recall that the gradient G, or let me start with the gradient giving us y2 minus y1 over x2 minus x1 is equals to G. Do we get? All right. So I can put this thing now as just y minus y1, just picking one point, one location, either here or there, as given to you. Do we get? Sometimes in the we are going to take as many examples as possible, so you are going to see what I'm trying to say, and that would be okay if you can, follow us by subscribing and clicking on the notification button so that you can be able to get these classes that will be coming up after now. So over x minus x1 equals to the gradient I have calculated so far as this line is concerned is 15 over 4. So you can see that I am picking this location. S is 2 and y is 5. So y minus 5 over x minus 2 is given by the gradient 15 over 4. So I will cross multiply here and simplify this. So in cross multiplying, I will have 4 bracket y minus 5 then equals to 15 bracket x minus 2. So I'll have 4y minus, this is 20 into 15x, this is minus 30. So you realize that this 4y is equals to, let this go over here, I will have 15x minus 30 plus 20. So I have y, or let me take 4y first, equals to, this is 15x, this will become minus 10. Is that correct? Yeah, minus 10. So divide both sides by, this is the equation already, but if I want to subject y, I'll have y equals to 15x over 4 minus 10 over 4. This is another way of obtaining the gradient of an equation, a straight line equation. Okay, if you watch here now, does this 15 over 4 look like the gradient to obtain there? Does it look like that? I'm sure you have seen it. It's 15 over 4 there. Look at it, 15 over 4. This will lead us to general equation for of a straight line. The general equation of a straight line. The general equation of a straight line y is equals, let me write it in bold so that you can see clearly, mx plus c. I'm sure that is very clear. Y equals to mx plus c. Of course, here now your c is negative, the intercept. This is the gradient, this is the intercept, the y-intercept. The y-intercept is the point through which the line cuts across the y-axis. All right, I am believing that, okay, I left one there, the midpoint. The midpoint is not difficult. Midpoint of PQ is simply, here you take sum of this plus this, that is x comma y, that is x2 plus x1, okay, over 2, comma, then this one be y2 plus y1 over 2. Just take the sum of here plus here divided by 2, comma, then here plus here divided by 2. That's the midpoint of the line. Okay, the midpoint of that line. All right, I believe that my explanation is very, very okay. This explanation I have given here is simply to introduce us to coordinate geometry, And I believe it is going to go a long way in helping us in doing the examples we are going to be looking at right now and in the next classes, and also from most of the why questions I'm going to be solving, we're also going to follow them. I believe that you will not lose out in anything. Please, the best thing to do is to subscribe to the channel so you can access all the classes we had already before now. And then if you click on the notification button and the like button just to say, oh wow, you've done well, you'll be encouraging us and you'll also be notified in the subsequent classes that we are going to be making. Thank you so much for following us.